Hi guys, what we'll do today is we'll solve an exact equation. If you remember, for exact equations, they typically give you the total differential, or it's how the question's asked. If you're given the total differential, can you find the function that it comes from? How do you do that? You integrate one of the pieces to give you back the function up to a constant, and then you differentiate it with respect to y and make the comparison to the right side, the derivative with respect to y, so that you can solve for this variable here. So it's sort of just like how can you manipulate the total differential equation to come up with the function that it originally came from. Okay, so let's try that. I've got an example here. Y cosine x plus 2x e to the y dx plus sine x plus x squared e to the y minus 1 dy equals 0. And this is our total differential here. Okay, so this left side here is the f sub x dx, and the right side here is our f sub y dy. So let's check that our mixed partials are equal. F sub xy will yield cosine x plus 2x e to the y. And if you figure f sub yx, we should get the same thing, cosine x plus 2x e to the y. These two are equal, therefore our equation is exact. Okay, so if they were not equal, then we could not use the method that we will show here for solving exact differential equations. So our first step is to integrate f of x dx so that it returns our original function up to a constant. Okay, so to do that, we will integrate y cosine x plus 2x e to the y, all in parentheses, times dx. And that will give us, let's see, that will give us y sine x plus x squared e to the y plus our variable constant g of y. Okay, and then we want to take the partial derivative of this with respect to y, and we'll make the comparison with the partial derivative with respect to y of our total differential equation that was given at the very beginning. Our total derivative, sorry. So we'll compare this with sine x plus x squared e to the y minus 1, and I get that from right here is what we're making the comparison to. So the right side stays the same, sine x plus x squared e to the y minus 1, but the left side becomes sine x plus x squared e to the y plus g prime of y. Okay, so these terms cancel out because they're on the same side, leaving us with g prime of y equals 1, or negative 1, sorry. But to get just g of y, we need to integrate both sides with respect to y. This would yield negative y plus a constant c. This time this is a true constant because we've already used the first time the idea that our constant was could have had a y in it, but this time there's no need to check for a functional constant with x. You can just use the regular numerical constant here. So now that we know what g of y equals, we plug that in here, or really here actually, and we say that our function then, and this is just the way it's written there, y sine x plus x squared e to the y minus y plus c. So our function is equal to this on the right side of the equal sign. Okay, and that's how you solve an exact equation. So let me recap. They gave us the total derivative, y cosine x plus 2x e to the y dx plus sine x plus x squared e to the y minus 1 dy. This is the total derivative, where this is f of x dx and this is f of y dy. Well, when we integrated this piece, because this was our derivative of f with respect to x, it gave us back our our function with a function of y constant, and that function ended up being y sine x plus x squared e to the y plus g of y. But we need to figure out what g of y is. How do we do that? We take everything here, its partial derivative, because our function's derivative with respect to y lies here on the right side, where this is f of y dy. And then we made the comparison to figure out what g of y is. So after we got that g of y equaled negative y plus c, we're able to plug it in and find that f of xy equals y sine x plus x squared e to the y minus y plus c. So there's another video I have out on an exact equation, so that one will also explain the same idea. Good luck and thanks for watching.